As we have become better at designing things, the terrifying scale of atomic and nuclear weapons has been rising exponentially ever since. Modern bombs have become smaller, yet more effective. But even today's nuclear blasts are nothing in contrast to what our universe is capable of. Soon we may design a weapon that could put an end to all life on Earth, and the idea for this devastating weapon may come from space. There was a time when we fought with swords and bows, but then we came up with an absolute war game changer: bombs. Atomic bombs mainly rely on fission, the process of atoms splitting into smaller atoms, where 50% of the energy is released as a blast, 35% as heat, and 15% as nuclear radiation. One of those was dropped on Hiroshima. Since then, we've created something that's at least 1,000 times more devastating: hydrogen or thermonuclear bombs. Unlike atomic bombs, fission is only used here to launch the second stage fusion reaction when atoms come together to make a single one. This collision creates a powerful burst of energy. This is also how stars produce energy, compressing two hydrogen atoms into a helium atom. And thermonuclear bombs are so frightening because they're powered by the same process. As of today, the largest hydrogen bomb ever detonated was the Tsar Bomba that had a yield of 57 million tons of TNT. The energy produced by this bomb would be enough to power a household of 6 people for more than 2 million years. But even this explosion was just 0.0000001% as powerful as the asteroid that wiped out the dinosaurs. Still, nukes are scary. Even people who would hide in an underground shelter wouldn't survive long enough because the oxygen levels in the atmosphere would drop to a critical level. But what if you found a shelter equipped with oxygen tanks and masks? Would you be safe? You might be in the event of a nuclear blast. However, there is a weapon so powerful that even a shelter with oxygen masks wouldn't save you. In 1923, 2 scientists discovered a very unique chemical element that can withstand extremely high temperatures and has a melting point at around 2,200 degrees Kelvin. The element is called hafnium, and it is used on rockets as heat shields. But this isn't how it gained its popularity. In 1998, a group of scientists launched an interesting experiment. And if all their calculations were right, they may have found a recipe for fist-sized bombs equivalent to 12 tons of conventional explosives. That's all thanks to hafnium. Hafnium-178m2 is a nuclear isomer known for its excited or energetic particles. But unlike most isomers, it can store massive amounts of energy for decades. In 31 years, it will only release 50% of its energy in the form of gamma rays. And if you consider its highest excitation energy among other long-lived isomers, you get a mind-blowing explosive potential. Just half a teaspoon of pure hafnium contains an amount of energy equal to 1 ton of TNT. That's roughly 10,000 times more energy per gram. Even a small working hafnium bomb would generate a massive explosion without using fission or fusion. And once it explodes, it could destroy everything in its path and even penetrate thick concrete bunkers. But how to release all that energy instantly and on demand? Currently, we don't know. But studies show it's possible. And despite scientists' skepticism, the Pentagon has become interested. Aside from that, the US military considered some other non-bomb weapons. One of those was a gun that could shoot gamma radiation in a coherent ray. Gamma ray bursts, GRBs, can be triggered by lightning or nuclear explosions. But most often, they occur in space as a result of a hypernova. As a huge star explodes, it emits gamma ray bursts visible for billions of light years. And the amount of energy of these bursts equals the explosion of a supernova, but is released in seconds or minutes instead of weeks. Now, imagine you have a weapon that shoots gamma rays or explodes like a bomb emitting lots of GRBs. Unlike nuclear blasts, gamma ray bombs would be clean, as they wouldn't disperse radioactive material everywhere. Gamma rays easily penetrate clothing, skin, teeth, bones, and can damage DNA. That's why this technology is so dangerous and desired. But can such a weapon be lethal? Gamma rays, like X-rays, can be deadly to the human body. They knock electrons out of an atom, which then get charged or ionized, disrupting chemical bonds as it goes through them. This destroys living cells, produces toxins, gene mutations, cancer, and often leads to fatalities from severe radiation sickness. But if the energy of a gamma ray is high enough, and you happen to be close to it, you'd be turned into ashes instead. Scientists have already managed to create a small version of GRBs in a lab, and who knows, maybe a gamma ray bomb has already been invented, but is being kept a secret. It's a long way till we design GRBs with the same amount of energy as those that happen in space. But a gamma-ray weapon exposing you to 5,000 rems of radiation would be enough to lead to spasms, brain damage, central nervous system dysfunction, heart failure, and be 100% fatal within 2 days. To compare, the radiation 500 meters, about 1,640 feet away from the hypocenter of the Little Boy explosion, was roughly 4,200 rem. One study shows that a theoretical 10 kiloton ground-level nuclear explosion in Washington, D.C. would lead to about 100,000 people receiving 150 rem and about 50,000 receiving 680 rem. But even if a gamma-ray bomb only exposed you to 300 to 600 rem, you'd only have a 50% chance of survival over the next 60 days. However, if a person succumbs to a small dose of radiation, it could happen within weeks or months, and that's why it's an invisible killer that leaves little or no traces behind, making any target nearly unable to defend itself. We human beings constantly evolve, but our process can be both beneficial and destructive. Soon, we may advance our technologies to the point where a single tiny mistake could threaten all life on Earth. What do you think about it? Let us know in the comments, and thanks for watching.